All right, let's talk trigonometry. Today, we're going to pull back the curtain on one of its key players, the secant function. It might sound a little intimidating, but trust me, it's way simpler than you think. Let's dive right in.
So we all know our good friend cosine, right? Good old adjacent over hypotenuse. It's one of the first things we learn in trig. But have you ever just stopped and wondered, what happens if we just flip it, What do we get if we put the hypotenuse on top?
Well, that simple question, that leads us straight to our topic for today, because it turns out that flipped ratio is actually a pretty big deal. So big, in fact, that it gets its very own name.
And here it is, meet the secant function, or sec for short. All it is, literally, is the reciprocal of the cosine. So, instead of adjacent over hypotenuse, secant is simply hypotenuse over adjacent. It really is cosine's identical, flipped twin.
Okay, so now that we've been properly introduced, let's get into the secant rule book. These are the essential tools you're going to need to really put it to work.
And here it is, you can't get any clearer than this. Side by side, you can see it's the exact same two sides of the triangle, just in a different order. Cosine, adjacent on top. Secant, hypotenuse on top. It's a perfect flip. That's all there is to it.
Now, this is super important. You grab your calculator, ready to find the secant of an angle, and wait a minute, where's the sec button? Don't worry, you're not crazy. Most calculators don't have one. No sweat. To find it, you just use this 1/over rule. You find the cosine of the angle first, then you just calculate 1 divided by that answer.
And this leads to a really cool property of secant. The value you get is always greater than or equal to 1. Always. Why? Well, think about it. The hypotenuse is always the longest side of a right triangle, right? And for secant, that longest side is on top of the fraction. You just can't put a bigger number over a smaller number and get a result that's less than 1. It's impossible.
All right, enough theory. The absolute best way to understand this stuff is to see it work. So let's put secant in action with a few examples.
Let's start with a nice simple one to get our feet wet. We've got a right triangle. We're told the hypotenuse is 13, and the side right next to angle A, the adjacent side, is 12. Our mission is to find the secant of A. And the solution is about as straightforward as it gets. Step 1, we know our parts. They were handed to us on a silver platter. Step 2, we just build the ratio. What's the formula for secant again? Oh yeah, hypotenuse over adjacent. So we just plug them in. 13 over 12. And that's it. Seriously, we're done.
Okay, ready to level up a little bit? This one's more of a brain teaser. We don't even have a triangle this time. We're just told that the cosine of some angle is 7/25. So, what's the secant? See, this is where knowing that core relationship really pays off. If secant is just the reciprocal of cosine, we don't need the angle, we don't need a triangle, we just need the cosine's value. We take that 7/25, we flip it upside down, and bam! The answer is 25/7.
All right, time for the challenge round. This time, we're working backwards. I'm giving you the secant, and it looks a little messy. It's got a square root. Your job is to find the cosine. Oh, and one more little catch. Your final answer can't have a square root in the denominator. Don't panic. Let's just break it down. First, we do what we know. To get from secant to cosine, we flip the fraction. Simple. But that leaves us with an ugly square root on the bottom, which is a big math no-no. So, step 2, we rationalize it. That's a fancy word for multiplying the top and bottom by that square root of 2. After that, we just clean up the fractions, simplify it, and we've got our clean final answer. Okay, hold on. Before we go any further, we need to talk. I have to address the single biggest point of confusion I see when people learn this. It's a simple trap, but it's so easy to fall into. Your brain sees secant, and it wants to pair it with sine. It sees cosecant and wants to pair it with cosine. It feels right, doesn't it? Well, as you can see here, it's completely wrong. Secant pairs with cosine. Do not let that first letter fool you.
So how do you remember this forever? Easy. Use the 1-co rule. In every single correct reciprocal pair, there is exactly one co prefix. Think about it. Sine pairs with cosecant, 1-co. Cosine pairs with secant, again, 1-co. 1-co per pair. Burn that into your brain, and you'll never make that mistake again.
Okay, so we've defined it, we've used it, but let's get to the real question. You're probably thinking, when will I ever use this? Well, let's see how secant actually shows up outside the classroom.
Imagine a ship sailing in a straight line past a lighthouse. If you want to know the rate at which the diagonal line-of-sight distance from the ship back to that lighthouse is increasing, guess what? The
The secant function models that relationship perfectly. It's used all the time in navigation and radar to understand these changing distances.
So at the end of the day, that's what secant really gives us. Sometimes it's just way more convenient to have the hypotenuse, often the longest or most important side, on top of your fraction. It's not just some new rule to memorize. It's a powerful tool that gives you the flexibility to look at a problem upside down.
So, we've officially demystified secant, revealing it for what it is, cosine's flipped twin. But that does lead to one final thought. If cosine has a reciprocal, what about the other functions? What other flipped twins are waiting out there for us to explore? Thanks for watching.